Hello class, here are the solutions to the Chapter 4 assignment for COP 1000. Other solutions could be possible as long as they meet the requirements. So here's the first program. The first program required us to, just by review, we want to examine the integers from 1000 down to 0, looking for multiples of 73. Going to print them all in one line, and then we're going to add them up at the end. So here's the code. We've got our accumulator set. We initialize it to 0. That's going to add up our numbers as we print them. We're going to start at 1000. We're going to keep going all the way down until we get to 0. If we find a multiple of 73, and there's the test for a multiple of 73, if you get 0 when you divide it by, as a remainder, when you divide by 73, then you know you have a multiple of 73, at which point we print it out and we accumulate by adding using the plus equals operator, we add the value of num onto our total. Now we need to reduce num by -1. And the instructions did say to examine every number. So we would subtract -1 from our num to eventually get down to 0. And then finally we print out the total. So there it is, and here's how it runs. Okay, there's the complete output there. All right, let's look at number 2. Program 2. Program 2. Let's just review what we had to do there quickly. Program number 2, we wanted to print a table showing the circumference and area of circles between a radius of 10 to 40 in increments of 45, and we wanted to control our output, so we got nicely formatted columns. So here's what we got for that one. We look at number 2. There it is. And let's make this window a little bit smaller. So as you can see, we're starting off by specifying a constant for pi. All uppercase is what you should do for that. And then we want to print out some titles and underline them. Now I did this with trial and error. There are other sophisticated ways of doing this, but we don't actually cover them at this point in our textbook. Now we want to look at numbers between 10 and 40. So using the range operator, we have to specify 41, not 40, and with an increment of 5. We calculate the area using the formula pi r squared. There's the double asterisk for exponentiation. And then we calculate the circumference, assign it to a variable circ, and then we print the radius. And then following, we end that line with nothing, right? We're using the end operator to end the line with nothing. And then we're going to format the circumference in a field 12 characters wide with 2 decimal places, and likewise for the area, 12 characters wide with 2 decimal places. So the output is something like this. Where is our output? Here it is. Okay. Next up, let's take a look at number 3. Program 3. This was probably the trickiest one, where we actually had to print a diagonal line. It's a little tricky. There could be other ways of doing this. As long as you have nested loops, you're okay. But there's the code that I came up with. And if we specify a certain number of rows, I'll go with 10. You should get 10 rows, and the final asterisk should be right up against the margin, as you can see here. Definitely the trickiest one. Best way to attack a problem like this, step away from the computer and pull out a pencil and paper. And finally, the last one, number 4. And for this one, we want to enter integers and add them up. So once again, we need an accumulator, which we set to 0. And then we have an initial read for entering an integer. And then we want a loop to continue while that particular value num is not equal to 0. So that's what's going to stop the loop right there when we enter a 0. We add our input onto the accumulator, and then we execute the continuation read. Now you'll notice that this line is an exact copy of the line before the loop starts. So that's what keeps the loop running. And then at the end we output the total. So here's an example. I'll go with 1, 2, 3, 4, 5, then enter 0. Total is 15. Hope that helps.